Hello everyone. Today we are going to discuss the mid paper for spring 2025. This paper has 5 questions. Let's go to the first question. The first question has 4 sub-questions in it. And the first question is, suppose we have two algorithms A1 and A2. A1 has an average T of n is equals to Pn square plus 1 minus Pn cube. A2 has an average T of n is equals to Pn cube plus 1 minus Pn square. Assume P is a probability value such that 0 is less than or equals to P less than or equals to 1. So, and the first sub-question is, determine the value of P when A2 will execute fewer instructions than A1 when N is a large problem size. So here we have to determine P. We were given A1 and A2. So we also have the information that A2 will execute fewer instructions than A1. Let's write that down. So first of all, there is also one more thing. N is a very large number. So here N is a large number, and A2 will execute less or fewer instructions than A1. So from this, we can take this inequality and solve for P. So we have the equations for A2 and A1, T of n's, in terms of P and N. So we have the information about N. So let's just put the both equations in place of these two, and let's solve for P. So first of all, for A2, it's going to be Pn cube plus 1 minus Pn square. Here it is. The A2's equation is less than Pn square plus 1 minus Pn cube. If we solve this, Pn cube plus n square minus Pn square less than Pn square plus n cube minus Pn cube. Let's just take all the p terms to left side and all the non-p terms to right side so that we can solve for p. So let's put pn cube minus pn square. These two to the left side. If we take those to the left side, we'll get them sign switched. So minus pn square plus pn cube less than n cube, that is here, minus n square. It changes its sign. So if we simplify this, it'll be 2p n cube, these two, and these two will be 2p n square less than n cube minus n square. Here, if we take 2p as common, 2p n cube minus n square less than n cube minus n square. Here, if we divide both sides with n cube minus n square, it's going to be 2p less than 1. So that is P is less than or less than 1 by 2. So yeah, we determined P when A2 is will run lesser or fewer instructions than A1. So that is our conclusion. That is the first question solution. That is the solution for A. And then for the B, so which algorithm runs fewer instructions when P is equal to 0? So we just have to consider that P is equals to 0 and solve for both A2 and A1, simplify those and determine which has fewer instructions. So let's go and solve A1 equation when P is equals to 0. Let's just substitute P is equals to 0. So 0 times n squared plus 1 minus 0 n cube. So this is going to be 0. This is just n cube. So T of n when for A1 is n cube. So for A2, T of n is equals to P n cube plus 1 minus P n square. So here, if we substitute P is equals to 0, 0 times n cube plus 1 minus 0 n square. So this is 0. This is going to be n square. So this is T of n when P is equals to 0. So here A2 has fewer instructions. So for B, the solution is A2. And when we, the next question is C, and it is very similar to the previous question, which algorithm runs fewer instructions when P is equals to 1. So when P is equals to 1, we just have to solve both equations for P is equals to 1. So yeah, when is first A1 is equals to For, for A1, the T of n is equals to P n square plus 1 minus P n cube. 1 times n square. We are just substituting P value here. 1 minus 1 n cube n square. This is going to be 0. So that is the A1 T of n when P is equals to 1. And for A2, T of n is equals to P n cube plus 1 minus P n square. So when P is equals to 1, 1 times n cube plus 1 minus 1 n square. So this will be n cube. This is just 0, so let's just take that away. So this is T of n for A2 when P is equals to 1. So A1 has fewer instructions than A2, so the solution is A1. And for the next question is if P has equally likely anywhere between 0 and 1, which algorithm runs fewer instructions the next time we run both of them on the same data? So they are running on the same data, so it doesn't matter what the data will be because both A1 and A2 will be running on the same data. So here the P value is between 0 and 1. So it is said that it's going to be equally likely anywhere between 0 and 1. So now we have to determine what will be the A2 and A1 instruction counts gonna be when with the P values. So we already determined that here in the first question that P is gonna be P is less than 1 by 2 when A2 runs fewer instructions than A1. So according to this, we can write this here. If this is 1 by 2, then A2 will be running fewer instructions than A1 here. Here, A2 will run greater than or equals to A1. So from this, we can say this. But here, 1 by 2 is middle of 0 and 1. So that's like half and half chance. So it's like they both are equally likely to happen. So we cannot determine which is going to be most likely to happen, like which is going to be happening more because they are equally likely. Yeah, so we cannot determine. That is the answer for this question here. And for the next question, that is all for the first question. And for the second question is on homogeneous linear roots. So for this question, we are given an, given the recurrence an is equals to 3an minus 1 minus 2an minus 2 with initial conditions a0, 2 is equals to 2, a1 is equals to 8. Find the closed form for an, find the general solution and specific solution using the method of homogeneous linear roots. So the first question is, and it has 4 questions in it. The second question too has 4 questions. So the first A question is finding the value A3 manually. So we already have AN is equals to 3AN minus 1 minus 2AN minus 2. And we also have A0 value and A1 value. These are given in the question. So when we are going to find the A3, we just have to substitute n is equals to 3 in this equation. We'll get the A3 value. So 3 times A n minus 1 is 3 minus 1, 2 minus 2 A n minus 2 is 3 minus 2, that is 1, A1. So we don't know A2 yet, but we have A0 and A1. So let's just find A2 and come back to this equation. So A2 is equals to 3 times. We just have to put n as 2 here. So 2 minus 1 is 1, A1, minus 2, A0. So 3A1 is 3 times 8 from here, minus 2 A naught is 2 times 2, that is 3 8 is 24, 2 2 is 4, that is going to be 20. So we have the A2 value here. So if we go and substitute this here, we'll get the A3. So let's do that. 3 times 20 minus 2 times A1 is 8. So it is 60 minus 16 is 44. A3 is 44, and that is our solution. for the first question and second question. And the next B question is finding the general solution. So for the finding of general solution, let's just write down the equation here. An is equals to 3an minus 1 minus 2an minus 2. So we just have to make an assumption that an is can be represented as r power n. So we have to substitute r power n in the an this equation. So r power n is equals to 3. This is n minus 1. So r power n minus 1 minus 2 r power n minus 2. So then later on we will divide this by r power n minus 2. So if we divide that, it's going to be r square is equals to 3r minus 2. This is very similar to a quadratic equation, so or else we can call this a quadratic equation. So we just have to find the roots for this quadratic equation and we'll have a value for our r. So let's do that. R square minus 3r plus 2 is equals to 0. So you can use a quadratic formula roots equation, or you can just get the roots like this. R minus 2 in product of r minus 1 is equals to 0. So from that r can be 2, 1 or 2. So the general solution is written in terms of these two roots. So that is an is equals to alpha times 1 power n plus beta times 2 power n. Alpha and beta can be any constants. If we have a few values of an, we'll be able to find the alpha and beta. So that is what we call specific solution, and we are going to do that for the next question. So here for the C question, we are doing the specific solution. From the question, we already have A2 and A1 values. So let's just write those here. A naught is equals to 2 and A1 is equals to 8. So we already have this equation. Let's just put our values A naught and A1 in AN and we'll be able to find alpha and beta because we'll be having two equations and two variables. We can find the equations and solutions from there. So A naught is equals to alpha times here A naught is already given, so that is 2 is equals to alpha times 1 power 0 plus beta times 2 power 0. So that is 2 is equals to 1 power 0 is just 1, so alpha plus beta 2 power 0 is also 1. So that is equation 1. And for the second equation, A1 is equals to 8. So if we substitute 1 in this equation, alpha 1 power 1 plus beta 2 power 1 is equals to 8. Alpha plus 2 beta, this is our equation 2. We are going to solve for alpha and beta from equation 1 and 2. So if we do that, from here, we can write alpha is equals to 2 minus beta. We'll substitute this in this equation. 8 is equals to 2 minus beta plus 2 beta is equals to 2 plus beta. So 8, 6 is equals to beta, or else beta is equals to 6. Yeah, we can write that. So from here, if we substitute here in this equation, the beta value, then we'll be able to get alpha is equals to minus 4 to minus 6. So yeah, we got our alpha and beta. We write this in our general solution and we'll be able to get the specific solution. So that is an is equals to alpha is 4 times 1 power n, which is 1. So we'll be taking that out and writing a new equation. Oh, alpha is minus 4 and beta is plus 6 to power n. We can also write this as minus 4 plus 6 to power n. 6 to power n. Yeah, that is our specific solution. And for the fourth question in the second question, the D question is use your answer to C to compute A10. So we have our solution for C here. N is equals to minus 4 plus 6 to power n. So if we use that to find A10, that is going to be just substituting the 10 value in place of n, minus 4 plus 6 to power 10. 2 power 10 is 1024. We can solve for that. You will be able to get this value, 6140. So moving down to the next question is the third question. It is on recurrence tree. So the question is consider a recursive algorithm with T of n is equals to T of n by 3 plus T of n by 6 plus n. So this is the recurrence equation given. Let's just write that down. T of n is equals to T of n by 3 plus T of n by 6 plus n. So the first, it has three questions in it. The third question has three sub questions. So the first sub question is draw a recurrence tree with at least three levels in it. So drawing a recurrence tree, we have the recurrence equation here. So first of all, the problem size is going to start with n. So it is going to be going into two recursive branches. One is T of n by 3, the other one is T of n by 6. So the problem size is going to be divided into n by 3. And here it is going to be to n by 6. And the work done at level 0 is n. So here the work done is n. And here the work done is here it is going to be n by 3. It is going to be n by 6. So of course, if you substitute here, you'll be able to get it. So it is n by 3 here, as this end is going to be same. So if we add both this and this, n by 3 plus n by 6 is going to be 3n by 6, which is 1 by 2n. That is the work done for 11.1. And we are told to do at least three levels. So let's just do that. For n by 3, if we substitute here, so it's going to be n by 3 by 3 from here. So n by 3 by 3 is going to be n by 9. N by 3 by 6 is going to be n by 18. And here n by 6 by 3 is n by 18. N by 6 by 6 is n by 36. So if we are all that, we'll be able to get the work done at this level. So n by 9 plus n by 18 plus n by 18 plus n by 36, which is 36. 9 fours, 36 plus 8 to the 36 plus 36 plus 36 ones. This is 9 by, this is going to be with n, 9 by 36n, which is 1 by 4n, which can also be written as 1 by 2 whole square n. This is not necessary in here, but it's going to be helpful if you write it like this because you're going to see something from this. It is the work done is here is n, here is 1 by 2n, here is 1 by 2 square n. So the work done here in each level is decreasing, and it is also decreasing with a ratio of 1 by 2. So that is what we're gonna determine from writing like this. So the second question is basically this answer. So let's just go for the next question. Is the work increasing or decreasing geometrically? What is the ratio from level to the next level? Yeah, so that is what I was discussing just now. So it is decreasing and it is with a ratio of 1 by 2 and it is geometrically. So, and the next C question is solve the recurrence with a closed form using the recursion tree to help you. The hint is infinite geometric series. So yeah, it's not, it is the tree is here, it is shown for three levels, but it is going to be continuing till we'll get the problem size as 1. So if it continues, it's going to be a infinite series. The work done going to be infinite series. So the work done, if we write it in an equation, it's the total work done is going to look like n plus 1 by 2, n plus 1 by 2 whole square, n plus 1 by 2 whole cube, and dot dot dot. And it's going to be a infinite series. So it is going to be, next we can write all the ends. We can take the ends out and we can write this as 1 by 2 plus 1 by 2 whole square plus 1 by 2 whole cube plus dot 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 plus. It is going to be something, some constant c multiplied by n. So we can write it as c n with the product of c. So let's find c. From geometric series, we already learned that infinite geometric series is the sum is going to be a by a minus r. So here a is the first term, which is 1. R is the ratio, which is 1 by 2. So c is going to be here the constant c. That is the equation. This going to be 1 by 1 minus 1 by 2 is 1 by 1 by 2, which is 2. So the sum is going to be 2n. So the closed form for the recurrence tree is 2n. That is the answer for the C. That's all for the third question, and then we'll move on to the fourth question. So for the fourth question, we have to know the Master's theorem. So all the 4 sub-questions in the Master theorem are based on the Master theorem. So yeah, if you know the Master theorem, you can solve this question. So let's see what is the Master theorem. Fourth question. If the equation, recurrence equation is as follows, T of n is equals to T of A times T of n by B plus F of n. And we then compare this F of n with n log A by B. We'll compare this and we'll be able to tell the closed form for the T of n by comparing F of n and n log A to the base B. So here there are 3 cases. Let's discuss first 2, 1 and 3 cases. Let's go for second case last. So this f of n is equals to, the first case is f of n is equals to log A to the base B minus epsilon. Epsilon is not something which is greater than 0. Then the T of n is going to be, the closed form for T of n is going to be theta of n log A to the base B. And next, the third one is f of n is equals to n log A to the base B plus epsilon. And then the closed form is going to be theta of f of n. And the second form, now we'll discuss the second form. Second form is f of n is equals to n log A to the base B log K to the base n. T of n is equals to theta of n log A to the base B log K plus 1 to the base n. This is the master theorem. So let's go directly to the questions and see them. So the first question is A is equals to, T of n is equals to 4T n minus n by 2 plus n square. Here, let's write this down here itself. So A is equals to uh, 4 from this. B is equals to 2. here, and f of n is equals to n square. N log a to the base b is n log 4 to the base 2. So if we simplify this gonna be n square log 4 to the base 2 is 2, so n square. So, so this is gonna be the second form here. So the solution is gonna be n log a to the b log k plus 1 n here for the log k n, k to the base n, k is equals to 0. So that's why the solution is n square log n. And for the next question, let's just take this down. And this for the second question, b t of n is equals to 4t by 2 plus n. So here a is equals to 4, b is equals to 2, f of n is equals to n, and n log a to the base b is equals to n log 4 to the base 2. So this is n square, and this is f of n is n, and n log a to the base b is n square. So this is gonna be case 1, and the solution is the closed form is t of n is equals to theta of n log a to the base b. So that is this. That's why here the answer is theta of n square. And for the C, let's write A, B, and F1 for C. A is equals to 4, B is equals to 3, f of n is equals to n square, n log a to the base b is equals to n log 4 to the base 3. N log 4 to the base 3 is n 1.26, so this is 1.26. So here f of n is n square, and n log a to the base b is n power 1.26. So that is going to be case 3 here. So case 3 here is t of n is equals to theta of f of n. Though the closed form is theta of n square for the C question. So let's just go to the next question, and that is D. The question is t of n is equals to 8t n by 4 plus n log n. Here let's write a, b, and f of n and n log a to the b. So a is 8, b is 4, f of n is n log n log a to the base b is n log a to the base 4. So if we simplify this using calculator, if you had one, so n 1.5. So that is also be written as n multiplied by root n. So if we compare root n with log n, root n is of course a bigger number. So the solution is theta of n root n, because this is gonna be the case 1. So that's how it is the solution. And that is all for the fourth question. Then next we move on to the fifth question. Fifth question is proof by induction of the sum of first n natural numbers. N is equals to n into n plus 1 by 2. So we have to prove this by induction. So if we are proving by induction, the main few steps in that are the base case, the assumption, and the proof. So first of all, we'll go with the base case. So here n is a positive integer. So n is greater than 0. That is what means that it is a positive integer. So for the base case, we'll be considering n is equals to 1. So this can be also, this is also be written as sigma I. where I is equals to 1 to n, which is also equals to n into n plus 1 by 2. So for the base case n equals to 1, here sigma I equals to 1 from 1 to 1 is just 1, which can be also written as 1 plus 1. Here, if we substitute 1 into 1 plus 1, fifth question is proof by induction. It is a question that requires proof that so we were already given the equation that we had to prove, that is 1 plus 2 plus 3 plus 4 plus n is equals to n into n plus 1 by 2. So also n is positive integer, so n is greater than 0. So first of all, if we want to do an induction proof, there are a few things like we have to have a base case and we have to make an assumption and then we'll prove. So first of all, let's go with base case. Base case is when n equals to 1. So when n equals to 1, this can also be written as sigma I equals to 1 from I equals to 1 to n I is equals to this equation. So for sigma I equals to 1 to 1, it's I is equals to, if we substitute 1 here, 1, 1 plus 1 by 2 is equals to 1 times 2 by 2, which is 1. And also, if we know by manual method, it is just going to be 1. So that is true. And next, we'll make an assumption that it is going to be true for j value, and j is going to be in between 1 and n. So let's write the assumption. Assumption is sigma of I equals to 1, I to j is equals to j times j plus 1 by 2. J is in between 1 and n. So this we are assuming that this gives a right answer for every j in between 1 and n. So if we maximize this assumption, so it's going to be true till n minus 1. So let's write this after maximization. It's going to be I equals to 1 to n minus 1. I is equals to, here in place of j, we'll substitute n minus 1. So n minus 1 times n minus 1 plus 1 by 2. So that just gives us n minus 1 and minus 1 and plus 1, so n by 2. Here, next we have to prove. So in the process of proving, we'll just substitute n plus 1 in terms of n here. So n is gonna be n plus 1. So if we substitute that, here n is gonna be n plus 1 minus 1, I is equals to 1, and I is equals to n plus 1 minus 1 times, here we are substituting n plus 1, here also we are substituting n plus 1, n plus 1 by 2. So that is going to be sigma I is equals to 1. And here, this is going to be n, I. Here, n plus 1 by 2. That is what we were trying to prove. So hence prove that is all for the fifth question. So that's all for this paper. And there will be another video on Thursday paper. And that's all. Thank you.